Hi everyone, welcome to SkyMap. Today we are going to talk about an asteroid sample on Earth. A special spaceship like a robot explorer named OSIRIS-REx went to a space rock called Bennu. This spaceship had a clever arm that reached out and grabbed a little bit of Bennu and put it in a little box. This box reached Earth on September 2023. That's our asteroid sample. But the whole process is not so easy. The whole mission took over 10 years and more than 1,000 people's hard work. So let's try to understand it in detail. Why NASA chose the asteroid Bennu for OSIRIS-REx mission? There are several reasons behind choosing 101955 Bennu among uncountable asteroids. Like, Bennu is a carbonaceous chondrite asteroid, which means it is rich in carbon-based compounds, but not pre-carbon. These compounds are essential building blocks for amino acid. This kind of asteroids were formed 4.5 billion years ago during the formation of solar system. So Bennu was expected to contain the early composition of solar system and can even describe the evolution of life on Earth. Secondly, Bennu is a near-Earth object, so never comes very close to the Sun. The asteroid doesn't experience extreme heat as well as extreme cold. So the building materials of Bennu haven't changed due to temperature. Moreover, the proximity to Earth has made the asteroid easy to reach. But due to this proximity, Bennu is also a potentially hazardous asteroid, which means it can collide with Earth in near future. Studying a potentially hazardous asteroid is very important for human being. The OSIRIS-REx spacecraft was launched by the Atlas V rocket on September 8, 2016 from Cape Canaveral Space Force Station. After Hayabusa and Hayabusa 2 mission from Japan Aerospace Exploration Agency JAXA, it is the third sample return mission and the first sample return mission for NASA from an asteroid. OSIRIS-REx chased Bennu for 2 years to match the speed of the asteroid. On 3rd December 2018, it reached Bennu. After understanding Bennu's gravity closely, OSIRIS-REx started orbiting Bennu on 31st December 2018. This is the smallest world ever orbited by a spacecraft. The 490-meter long asteroid was thought to be a body surrounded by fine grains like sand. But after approaching, it disappointed scientists with rocky scape dominated by boulders. The biggest boulder on Bennu, named Rock Saxum, is bigger than a football field on Earth. Mapping the surface of Bennu was tougher than scientists ever imagined. Originally, they thought to map the surface with LiDAR sensor only. However, the severe condition forced them to take the help of high-resolution cameras to map the surface. The OSIRIS-REx broke the orbit several times and re-entered the orbit to conduct a detailed survey from different altitude. It orbited Bennu for 505 days. At last, it mapped Bennu in only 5 cm per pixel scale, which is the highest in any planetary body, including Earth. This picture of Bennu reveals dynamic activity. It's clear that Bennu is ejecting particles in space. Even some of them are orbiting the asteroid. Due to the continuous collision with solar wind and radiation, the rotational speed of the asteroid is increasing. It's called the Earp effect. This accelerated rotational speed is gradually increasing the centrifugal force of Bennu. So, it is unable to keep the objects gravitationally bound. This increased speed can even disintegrate the asteroid one day in future. In early 2020s, OSIRIS-REx shortlisted 4 suitable sites for sample collection: Kingfisher, Osprey, Nightingale, and Sandpiper. Due to the high number of boulders, it had to choose the site carefully, otherwise the boulders could disturb the sample collection process. At last, the Nightingale site was selected because Nightingale is a crater with relatively small rocks, and the crater is the best place to study underneath Bennu's surface. The plan was, after synchronizing with Bennu's gravity and matching Bennu's rotation, OSIRIS-REx would slowly descend to Bennu, extending the robotic arm. After touching down, the thrusters will turn on to stop any further descent. Then it will blow high pressure nitrogen gas from the arm, which will help the gas, dust and small rocks to come in. A filter will trap the dust and rock while allowing the gas to escape. This mechanism is just opposite to a vacuum cleaner, as space itself is a vacuum. OSIRIS-REx performed 2 practice runs to recheck that everything was working perfectly. On 15th of April 2020, it performed its first practice run, reaching 65 meters from Bennu. And on 11th of August 2020, it performed its second practice run, reaching 40 meter altitude from Bennu. Now, the most crucial moment has arrived. On 20th October 2020, OSIRIS-REx started its final descent. Any real-time remote control of that spacecraft is impossible due to the distance, as any signal at that distance will take several seconds to reach OSIRIS-REx. Moreover, during the final descent, the data transfer speed from Earth was only 40 bits per second, as it was not in perfect angle with Earth, while prioritizing the descent only. So, it raised its solar panel in Y-shape to protect it from any flying dust, and started descending at a speed of only few centimeters per second. At 4:11 PM Mountain Time, scientists got the confirmation that OSIRIS-REx has touched down and collected the targeted sample, which is only 60 grams. After collecting the sample and reaching a safe distance from Bennu, OSIRIS-REx came to the perfect angle to transfer data to Earth. After seeing the final data, scientists were stunned and also amazed. Bennu is a small body with low gravity, so the matters are very loosely packed. Scientists knew that and added a spring to the robotic arm. They thought while touching down, the spring would absorb the shock and contract. Realizing that, the spacecraft will also stop the descent and collect the sample. But the Bennu is so loosely packed that the spring absorbed only 70 Newton shock, which is so little that the data didn't even register. This was scientists beyond expectation. So the robotic arm kept going in Bennu, reaching almost half meter in the Bennu. At this point, realizing the emergency, OSIRIS-REx thrusters went into overdrive mode, arresting the further descent. It burned the highest amount of fuel in its whole life. This disturbance scattered almost 6 tons of rocks in all directions. It created a new crater on Bennu's surface. Although NASA didn't imagine this extreme, then also the emergency situation was pre-planned. It collected over 400 gram sample from the asteroid when the target was only 60 grams. The quantity of sample was so high that one flap of the sample collector was stuck due to a rock. So some amount of sample was lost in space. This mission was a huge success. On 7th of April 2021, OSIRIS-REx visited Bennu again to see the site night angle. It saw a huge crater. Just for reference, this rock has moved almost 12 meters on Bennu's surface. Then it started its return journey to Earth. On 24th September 2023, the asteroid sample returned to Earth. There are many meteor samples already present in Earth. But this time what's different is the asteroid sample haven't reacted with Earth's atmosphere. It haven't burned up while entering the Earth's atmosphere. NASA used proper heat shield on the return capsule. It landed on Utah Desert and already been transported to Johnson Space Center. NASA believes there is almost 250 gram sample present in the capsule, as we have lost some sample in space. They even found lots of asteroid dust and small rock outside the sample collector. This sample haven't interacted with Earth's atmosphere till today, as it is kept in a nitrogen-sealed area. Scientists have found different shapes of small rocks and dust in the capsule. In this image taken by electron microscope, you can see water crystals. You can also see the sulfide and iron oxide, the building blocks of amino acid. In this image, you can see the carbonate minerals and organic compounds. The percentage of carbon present in this sample is almost 4.7%, which is higher than almost all celestial bodies. There is a hypothesis that the water present on Earth may have come from asteroids. In future, this may come true. Finding building blocks of amino acid in an asteroid is truly fascinating, because amino acid is the basic material for life. What do you think? Have asteroids brought life to Earth? Please write it down in the comment section. I would love to know your thoughts. Can you remember? Behind choosing Bennu, there was a cause of near future collision with Earth. It can collide with Earth in 2135, though the chances are very low. But studying this kind of asteroids gives additional knowledge about potentially hazardous asteroid. So, after ejecting the capsule in Earth's atmosphere, OSIRIS-REx has started another new mission called OSIRIS-APEX Explorer or OSIRIS-APEX. On 13th April 2029, a 370-meter long asteroid named 99942 Apophis will come as close as 32,000 km to Earth. OSIRIS-APEX will observe the changes of the asteroid as it passes near to the Earth. And it will also fire the engines to kick up loose rock and dust from the asteroid. This will help humanity to study the potentially hazardous asteroid more closely. If you found this cosmic journey as fascinating as I did, please give this video a thumbs up and share it with your friends and family members. And remember, keep looking up, stay curious, and explore the mysteries of night sky.